So today our topic is relational algebra. So we will learn relational algebra, tuple relational calculus and domain relational calculus in this class. First I will discuss 6 basic operations of relational algebra. First is select. Consider a relation R that has 4 attributes. Now I have previously mentioned that if you represent a relation in a table, then columns represents the attributes. And each row represents each row is called tuple. Okay, so here in select operation you have to fetch tuples based on some conditions. Now for this case here, what is the condition? A equals to B and D is greater than 5. You have to fetch the rows of the from the relation R where A is equals to B and D is greater than 5. Now in the first row and third row you can see the values of A and B are same. So first row, third row and fourth row, the values of A and B are same. Now in the first row, let's see what is the value of D. The value of D is 7, which is greater than 5. So first row is satisfying the condition. So fetch first row. Second row is not satisfying the condition because A is not equals to B. Third row, again A is equals to B, but B is less than 5. So third row is again not satisfying both the conditions. So now go to the last row, fourth row. A is equals to B, yes, and D is greater than 5, yes, because the value of D is 10. So first row and fourth row will be fetched. So the result will contain this first row and fourth row. So this is the select operation. In select operation, you are fetching the tuples. In project operation, you will fetch the columns. In the previous case, we are fetching rows. Now we will fetch columns. So project operation, you will fetch attributes or columns. So again relation R, we have 3 attributes A, B and C. You have to fetch attribute A and C. So that means the columns A and C will be fetched. Now what we will get? Alpha 1, beta 1, beta 2. So alpha 1 is getting repeated. So 1 will be removed. So the result will be alpha 1, beta 1. So result will contain a relation with 2 attributes A and C. The rows will contain A alpha. Rows will be alpha 1, beta 1 and beta 2. Okay. So this is the project operation. Now is union. In set theory, you have already read what is union, how union is done. So here also, if you consider both two relation R and S, then the union will contain both the tuples. Both the relations contain the tuples of both the relations. So here in R we have two attributes A B. In S also we have two attributes A B. All rows from R and S will be taken in the result. So alpha 1, alpha 2, beta 1, alpha 2, beta 3. So alpha 2, alpha 2 is in R as well as in S. So the result will contain alpha 1, alpha 2, beta 1, beta 3. Okay. So all the rows will be considered. In set difference, the common values will be removed. R minus S. So what is the common row here? Alpha 2. So alpha 2 will not be there. R minus S. So it will contain alpha 1, beta 1. If it was S minus R, what it will contain? Beta 3. Okay, as this is R minus S, all the rows of R will be fetched except the common one. So alpha 1, beta 1 is the result. Next is intersection. The common value will be fetched. Common row will be fetched. So what is the common row here? Alpha 2. So alpha 2 is the result. So you can represent the intersection as R intersection S means R minus S. Okay. Now next is Cartesian product. Now before going to the natural join, first consider Cartesian product. So Cartesian product, what happens? It is just like you are doing product. So if you have a relation R, here we have a relation R that has two attributes A and B and two tuples. And we have another relation S that has three attributes C, D, E and it has four tuples. So in the product, after doing the Cartesian product, in the result you will have 2 into 4, that is 8 rows. Now how it will happen? In the result, you will have all these attributes A, B, C, D, E. So now consider this alpha 1. Alpha 1 you consider alpha 1, then consider all the 4 rows of the second relation. So alpha 1 alpha 10A, alpha 1 beta 10A, alpha 1 beta 20B, alpha 1 gamma 10B. Now consider the second row of the relation R. So again consider the second row and all the rows of the second relation. So beta 2 alpha 10A, beta 2 beta 10A, beta 2 beta 20B, beta 2 gamma 10B. So we have 2 rows only in our relation. So we have generated the result. So 8 rows will be there. So this is the result. This is the table. Now, in case of natural join, we'll have some common attributes. If it have some common attributes, then only the common things will be considered. So, first, in case of natural join, first what happens? First, the partition product, and then based on the common attribute values, it will project only those things. So, it's first select and then project. So, it is a combination of 3 operations for partition product. Then on that, selection will happen. Select operation will be there, and on that result, a project operation will be there. So now let's see how it is happening. So here we have 2 common attributes in R and S, B and D. So only common values will be considered. This alpha. So in the final table, it will contain result table. The attributes will be A, B, C, D, E. Then here you can see alpha 1 alpha A 1 A alpha. So B D, here B value of B is 1, D is A. Here also value of B is 1, D is A. So these row will be considered. So alpha 1 alpha A alpha. Next, the value of B is 3, value of D is A. So no match. Again, third row 1A gamma. So again match. So alpha 1 alpha A gamma. Third row, again no matching. This is 2B, no matching. Fourth row no matching. Fifth row 3B, again no matching. So only first row and third row is matching. So alpha 1 alpha A alpha, alpha 1 alpha A gamma. Now consider the second row of the first relation. So 2A, there is no 2A in S relation. So now move to the next row, third row of R. 4B, there is no 4B in S. So again go to the next row. Again 1A. So alpha 1 gamma A 1A alpha. So alpha 1 gamma A alpha. And here alpha 1 gamma A 1A gamma. So alpha 1 gamma A gamma. Okay. Now consider the last row. Here delta 2 beta B. The first one is 1A, so no matching. Next is 3A, no matching. Next is 1A, no matching. Fourth one is matching, so 2B. So delta 2 beta B, 2B delta. So delta 2 beta B delta. The last row is not matching. So here how many rows we are getting? 5 rows we are getting. Okay. So this is the result of natural join among R and between R and S. So next is rename. The results of relational algebra are also relations but without any name. The rename operation allows us to rename the output relation. Rename operation is denoted with small Greek letter rho. The result of the expression is saved with the name x. If you want, you can rename. Give a name. Name to it. Okay. Next is outer join. In case of natural join, what you see that in case of natural join, you're considering on the common values and these things. So there is no null. So inner join selects rows from the tables that fulfills the join condition. Using inner join, the data specifically the rows from both the tables that do not satisfy the condition are lost. Outer join can be used to prevent the loss of data from the tables. As inner join, you are not considering the other values, so you are considering the common values. But if you want consider other values also, you do not want data loss, then you can do outer join. Because in inner join, you are not getting null, you are not considering that. But in case of outer join, you can consider null. So in inner join, what happens? The rows from both the tables that do not satisfy the condition are lost. But here to prevent data loss, this outer join is performed. Outer join actually what it does actually computes the join and then add tuples from one relation that does not match tuples in other relation also. The result of the join. Okay. So it can contain null values. So now consider relation loan, another relation borrower. So here you can see loan number, branch name, amount. So here loan number is the common attribute. Roll number 170, 230, 260 is present in loan relation. In borrower relation, 170, 230 is present, 260 is not present. So whenever you are doing a natural join among these two or inner join among these two, then we will lose this L260 as you can see here. But if you do an outer join, then you can do it. You can get this value. So outer join can be left outer join, can be right outer join, and can be full outer join. So first left outer join. Left outer join, left one is considered, you are considering all the tuples will be fetched from that relation. So from the loan relation, you will fetch all these three tuples and consider these values. So now L170 downtown 3000 customer name is Jones. 230 Redwood 4000 customer name is Smith. 260 Perry Reach 1700 but there is no customer name. So what you will place here? Null. In case of right outer join, all the rows, all the tuples from the second relation will be considered. Okay, so here you can see 170, 230 and 155. So loan number 170 downtown, L170 downtown 3000 zone. L230 Redwood 4000 Smith. L155 there is no branch name, no amount. So null will be there. Customer name is his. Okay. And customer name is his. Okay. Now full outer join, you will consider both the tuples from both the relation. So what you will do there? Again L170, L230, downtown 3000, Jones, Redwood 4000, Smith will be there. Next L260, Perry Ridge 1700, null. L155, no branch name, no amount, null, his. So all the tuples from both the relations will be there, and here you are getting these two tuples. In the first, in one case you are getting null in customer name, and another case you are getting null in branch name and amount. Okay. So next is relational calculus. Relational calculus is a non-procedural query language. That is, it tells what to do but never explains how to do it. Relational calculus exists in two forms. One is tuple relational calculus, another is domain relational calculus. In tuple relational calculus, filtering variable ranges over tuples. First, it returns all the tuples if you consider T then condition. It returns all tuples T that satisfies the condition. For example, T dot name, author T, and T dot article is equals to database. It will return tuples with name from author who has written article on database. In domain relational calculus, filtering variable uses the domain of attributes instead of the entire tuple values. So article page subject, it is Pearson and subject is database. So provides article page and subject from the relation Pearson where subject is database. Okay. So thank you.